Hello. Okay.
Sir.
Am I audible? Yeah, good.
Yes.
Okay. So, how is the course going on? I think we have completed 4 lectures, and I think we have released the assignment also, right? So, there was a slight mistake in that. I did it through code, so I had a small mistake there. I tested it. I don't know. I didn't open the link actually. I have tested everything, but I have not opened the link to check whether that is that same paper or not. So I thought, okay, that would have been the same thing, but okay, no problem. So my kind of intent is not to have the paper. My intent is to ensure that you read a paper as part of this course, which is more relevant to the first half because I don't want to give some more like complicated papers which will be related to the second part. So that is the concept. It doesn't matter which paper you take. In fact, I had initially thought, okay, I'll give an option to you guys to prepare, like take up the paper. Like last time, I guess I gave more options. Like I gave only the topic last time. I didn't give any topic, sorry, exact link to them. But this time, what happened with that, I'll tell you. Then I will justify why I went for this link logic. Is because when you give the topic, students take up any random paper and which is not very interesting or which is not related to the subject. So I just wanted to collect some paper links myself so that whichever paper among that I think 116 papers I have collected, I guess. So if I am correct, I have to check the links. So around 116 papers. So personally, I have collected. So it took some 2 hours. So, but I just wanted to ensure that each and every paper, any paper you can read in that, and you will get something for learning related to the course. That's what my intention is. That maybe see sometimes what happens, it is a torture. Assignments are torture. Many people consider it like that. Those who just want degree, right? Those who really are interested will always find the best one out there. But those who just want the degree, they don't want to attend the classes and they just come here to get the MTech degree and go ahead. Yeah, I know that because I have also done here. So those who get that, obviously, then they will go and blame that, okay, bits have not given a okay, good knowledge. So it's easy, right? You don't do hard work. If you pay, everything could not be injected into your brain. You have to do the second hard work. It was there same as in BTech also, right? So when I studied in NIT Trichy, every facility they will give you. But at the end, you have to sit and read. It's not like that NIT graduate, everybody is intelligent, right? Or IIT, Manlo. But if you have to pass, if you pass, there are people who can pass also without studying anything. We can see they are also graduate, they are also BTech, they are also MTech. But who studies will go far in life. In fact, I consider I am an average student if you consider in my batch in NIT Trichy. So there are a lot of guys, my topper, he went to MIT, Sloan University. He is like earning in crores, like per month ka crore hai. It's like that. I don't know how much, maybe more than that, in fact. So he's like top guy. So we talk, but the use of what he used to get up at 5 o'clock, study, and during exam he will be very much relaxed. It's an awesome thing I learned from him is like during exams is very calm, nothing, no tension. We'll all be struggling. कौन सा xerox लेना है, कौन सा photocopy लेना है. It's not like he has brought in some great intelligence. It's just that right hard work at the right moment is important. I'm not saying that, see, it's not always MIT Sloan or somewhere is best. So, what you think you have to lead your life, or what makes you happy and your associated people happy, family happy, that should be your aim. So, I also have that thought process that, like, what do you say? Studying and achieving, like, achieving is, what is achieving? Achieving is like you are going as an IAS officer or something. Is that called an achievement? Yeah, maybe for some people who think that is an achievement, that's an achievement, right? So if you think that, okay, living happily, not hurting anybody else itself is a great thing, which is impossible actually. If you want to grow up in your life, that second part is very difficult. You can live very happily. You can roam around the world, do everything. But all those things, whatever you do, if you are doing it at home or travel or anywhere, but none of these should hurt anybody else in this world. It's very philosophical sentence, but it's very difficult. If you can live that life, that is also an achievement. Or you become a CEO of a company, you own a company, or you become the topmost guy in the company or the tech world. So these are all happiness. But what I'm saying in academic point of view, so since you have put in money here, so you have to take it back. It's as simple as that. So coming back to the course, don't want to be too much philosophical here. Many will not like it, right? In fact, many of my advices, I myself don't like it after 5 years. So it depends on your current mood and current lifestyle. You gives your gyan, whatever gyan you want. Okay, coming to the course again. The course is like,
There's
since
one.
you, yeah, let me complete it. Let's have the discussion here. We have so much time because I guess we are ahead of all other sections. So technical doubts also we have more time. Okay. So let me complete what I wanted to say about the course. So since you have put in money and time here, so you have decided, right? So your own wish. Nobody has compelled you, I guess so, until your company is uh, like uh, like mandatorily told you to do the bits and tech. So it's your choice. So since you have chosen it, extract how much ever possible from here, because they'll leave everything else, degree, other things. You have to take the ROA, right? Return on investment. So you put in 3 lakhs, you have to get 3 lakhs because of this. So by default, you will get promotion, you will get an increment in your company. But because of this MTech, what are you going to take more? And I can guarantee, if you are not able to get it, it's your own mistake. It's as simple as that, because I can guarantee I have taken 10 times more than that. Okay. So I have seen people who have taken 10 times or 5 times more than that. So you can also get it. It's not like that, don't say nobody is respecting this, not that, and all is sub your own intention. You don't know how to bargain. It's as simple as that. How you don't know how to project it. I think I discussed in the first class. I don't know if your class or some other class. First learn. It's not like that you degree certificate throw karega, somebody will give you 10 lakhs. No, nobody is going to give you. No interview. Even I am a manager. I don't recruit based on MTech. I will prefer MTech, but it's not based on MTech or BTech. If you can bring in value to the company, then only I can give you more money. So value के लिए पढ़ना पड़ेगा है ना. So you have to study, you have to learn, improve yourself. You should talk in a language as an MTech guy. If you cannot talk in a language as an MTech guy, you are still a BTech. Doesn't matter you have a paper of MTech degree or not. I hope everybody agrees with this. Maybe it is hard hitting for people. There is one more outlier case, hard hitting for people who don't study, but there is an outlier there. There is one more category. Like, one category is they would have studied, and another category is not studied. That is okay. So clear cut understanding. But there is in another one category, those who studied, but they do not know how to talk. Understand? That's in data science. We have a course called storytelling. Okay, it's not like general storytelling, technical storytelling. You should be able to talk to your management. You should learn to talk to your management in a way they understand. You may be tech geek, okay, you may be very intelligent, you can code in 5 minutes, 10 minutes. If you do not know how to present it, you will obviously see until you deliver something to somebody in a way they wanted, how will they understand and give you 10 lakhs more? Correct. It's as simple as that, right? It's like you sit and it's like बोलते हैं ना, you sit silently, your friend will understand. Yeah, that is your friend. But those who give you 10 lakhs is not your friend, right? So you have to tell them in a way they understand your value, where the technical expertise, what you have developed and what you can contribute. So you have to talk it out, but you should talk it in a way the and it is not one way. And another thing is it is not one way. It's not like you talk to me in a way maybe different from you talk to your manager. So you should be flexible while talking. That is why it is very difficult. Storytelling is difficult because it's not like it is just one way to tell and you will talk to every audience. No, you should uh, like instantly change your way of discussion, talking, delivering based on what is your audience. So initially you do not know the audience or you know the audience. Like in companies, you know your management, you know your current boss, so you can deliver. But to your new company interview, in a new company interview, you'll not know who is the manager. Maybe you know something in their LinkedIn, but they will not be same as that LinkedIn profile, right? So you have to judge that in 2 3 minutes, so that by asking one or two questions or by understanding how they answer, they talk to you. So from that you should guess, okay, what kind of person he is and how we can talk to him so that he understand. He's a very requires a lengthy talk, or he requires a very highly technical talk, or he is a very layman. So these things you should understand, and then like maybe I hope you understand this logic. Okay. Okay. Yeah. Coming back to the query. Any queries? Yeah, somebody was saying something.
Yeah, I just is that possible that we will have those research doc? Actually, we've done most of the work that we don't need to go and search all those research document. Is that available for us to, not for the doing the assignment, but to understand the concept? Is it available for us to go through those list of
All the
research
papers.
papers? Yeah, we are not
Oh,
going to
you
study,
want the
but
list?
yeah, yeah. So
Okay.
that is that available in some kind of SharePoint so that we can also take a look.
Oh, okay. That I will share it. Don't worry. Okay. You ask me later. You can ping me. I'll share it with you. Okay. I
Okay,
don't want to
thanks.
put it so in open because it will become a course content. Then there will be a lot of emails asking whether everything has to be read, because those who do not even watch the recording, they will directly have so much you understand my perspective, right? As a prof, they will simply come and email. There will be 20 30 emails just before the mid exam when they will start going through the subject, and then they will just email. They will study or not, they will first understand whether what is the content. They will send 30 emails saying that, okay, whether we have to go through all the 116 papers. This is too much, sir. करके सबको explain नहीं करना है. Okay. So whoever wants, just ping me. I hope that will be less than the emails what I will get. Okay. Yeah, that's a good ask. Anything else? Okay. Anybody else wants to share something related to this course in your company, or even this course feedback you want to share, how it's going, whether you guys are learning, not learning, it's too much content or less content. You guys are very silent. Don't want to talk or what? Arey, don't be afraid. You are not even in front of me, right? Just voice. I will forget even who talked because there are a lot of people here. 48 people. In fact, there was one class last year. I took two sections last semester. One class till the last class, only one guy attended. One class, I think it was during some function or some, I think some festival. So just only one person came. So I could really remember his name. But this class, there are a lot of people. Good to see that. I hope I'm giving some value or just boring talks because I understand that there is no additional marks for attending class, right? So if you guys attend the class, a lot number of guys attend the class, I like passively I consider this as an compliment to the value I deliver.
So no, sir, this is interesting and helpful. This is Prabhu there, and just wanted to check on the assignment. I'm not sure it's been covered earlier or not. I joined a little late in during the
Hmm.
discussion. So on the assignment, we have a a condition for a peer review and feedback, right? So and the
Hmm.
person with whom you are taking that feedback should not have the same paper assigned as yours, right? So
Yes,
in that
yes.
case, one person has to go through three papers, right? In a sense, because they will
Not
provide the
in
feedback
a
only when
sense.
they, yeah.
Yeah, yeah, yeah. You complete your question. Sorry, sorry.
I was just saying, to just to provide the feedback, they
Hmm.
have to understand it and provide the feedback. So they are doing their paper and they are providing feedback to two other papers, right? So
Hmm.
yeah.
So it's difficult, right? No.
So it's
So
looking at the timeline, yeah, looking at the timeline, sir.
no, Avinash, Prabodh, sorry. No,
Yeah,
Prabodh.
yeah.
See, my intention is, yeah, I am very pathetic guy who wants to make you guys learn. You can scold me at the back end, no problem, but learn something. That's the first point. But coming to the assignment, it is not so difficult like what you thought. Okay. What is written in the assignment only I tell. It is not my intention. That is written also in the assignment. I think you have understood a little bit differently. The first paper which is assigned to you or you have chosen among those two papers, it's yours. You will read everything out of it and learn everything from the paper. Okay. So, and then you will prepare some 8 slides, right? So that is the first 8 slides of the format. And now you will find two persons who are not having the same paper and give a presentation to them. 15 minutes ka presentation. I guess I have mentioned that. So you will give a presentation. Suppose you are the person, you are giving me 15 minutes presentation. I have to give you a feedback based on what I have learned from your presentation, not on the paper. I'm not
Okay,
supposed to go to the paper. So what is this? Why this is exactly what I was telling few minutes before. Maybe I confused it inside that the date storytelling logic.
got
Okay.
it, got it.
So
Yeah,
you
I can
learn
imagine.
it and you are delivering it to somebody who has not read that paper. That's the important. That is why it is not the same paper. That is the first point. Second point is the second person is learning only from your presentation. So it tests two things, your presentation skills as well as your slide preparation skills. Correct? So
Makes sense. Yeah,
that makes sense, right? So
yeah.
it's very important. And this is the place where you can learn. I always wanted my juniors also to learn in my team company. So I arranged this kind of useless stuff for them. They scold me at the back end. Yes, I of course accept it, but it will be helpful for them when they become managers. It's simple that it's I am a manager and I want them to become my successor. Like they will be my back. Even if I leave the team, there is sufficient energy there to continue. Right? That's very important, right? So nobody is permanent here. So same thing is for here also. You have to learn reading paper. That is an important part of being a technical guy. Correct. Second thing, you should know how to talk, how to deliver it in a way, in a simplest way, such that a person who has not read the paper will also be able to understand within 15 minutes. even though that paper is 100 pages. It's very important. That's an art actually. If you don't
Got it.
learn
Got
it in a college, it's impossible you learn it in a company. So maybe it is possible to learn in company, but it will take more time. But in college, this skill is not directly mentioned skill. You should learn. That's my intention of this. So 2% vibe is just 1% maybe very close friend of yours. So he may just अरे यार आप ही ऐड कर दो कोई feedback. क्या ही 15 मिनट कौन चेक करने वाला है ना? Oh, nobody is checking. So 2% I wanted to make sure that okay, maybe one guy, maybe you guys have another 5 friends, but my intention is please don't do that stuff that uh, like अरे दो friend का नाम लिख दूं. I will write your name and I will give my own feedback. Nobody is going to check whether I had a conversation with you for 10 minutes or not. Right? Please don't do that. If you understand my intention, na, that it will develop your presentation skills and slide preparation skills, right? So if you
makes sense.
genuinely
Yeah.
think, okay, you are learning here, you do that. If you think, अरे as usual, time नहीं है, company में बहुत तीर मार रहा है इधर, time नहीं है, then you can continue with that. But it is just killing your own, what do you say, learning point. You have to spend that time, but we always justify, not we, I have never done that, but many people justify that अरे company में बहुत time बहुत काम है, so we are not able to just spend time for the assignment. I'll see in the assignment too. This happens till your death. That's my truth. If you want to learn, you will learn. You will always find a time. If you don't want, you will always find an excuse. Okay. Yeah. Any other questions? I hope I answered Prabodh, right?
Yeah.
Okay.
Yeah.
Yeah.
Makes sense.
Yeah.
Yeah.
I got your
Thank you.
point.
Oh,
Thank
yeah.
you.
One question, sir. I mean,
Yeah.
it's regarding. I was working on a Chat GPT kind of a bot,
Mm-hmm.
and I realized that whenever we make a session and to a backend model, the
Mm-hmm.
context is preserved. But I mean, let's say if I have say, asked some query and I have shared some data. At the same time, I can ask, but if I ask later again in a new session, the context is not preserved. So have we covered this in class, or we will cover how to like ChatGPT? We can continuously ask the same questions, like
Mm-hmm.
about the same context.
Mm-hmm.
So,
So
so
where are
I
you storing your say, session memory? Of course, it
okay.
will not be there for the next session because
Mm-hmm.
it's a different call, right? So,
Mm,
but you have to store it, right? How will you give it to LLM? For
okay.
to store it, give it to LLM, you have to save each sessions at the back end. There are two, three concept layers of memories. I guess we will cover those. Last class, what did we have? No, we will cover this. Don't worry. It is in the prompt engineering. It will be there. Somewhat it will be there. I don't know whether I'll go in deep or not, but of course, I cannot teach you exactly like your company work, right? That's
Yes,
beyond its academic.
I mean,
But
it's very
you will
yeah.
understand that there are different layers of memory where you have to store session. It's not, see, that's what I always tell. Chat GPT is different from making a call to a GPT or LLM is completely different from setting up a complete conversational AI system, right? So the memory part, and nowadays it's called as context engineering, right? I guess if you understand context engineering, that's what exactly you're looking for. If you don't want to wait for the session, go and read about context engineering. You will understand everything. You will get the
Okay,
answer for what you asked for.
okay, sir. Sure.
Okay. Is it the thing what you wanted me to answer? Ideally, I didn't
Yes,
give the
sir.
answer.
I mean,
Yeah.
yeah, same. Similarly, for example, if I share some vulnerability report, I have just
Mm-hmm.
given to LLM. And then first
Mm-hmm.
question means along with the report, I just ask, summarize it. That is easy. But if I subsequently ask some more questions, like just give me particular component report or how to fix it. So these are subsequent queries. So I was
Mm-hmm.
just trying to do in multiple sessions. So it was
Mm-hmm.
not recognizing basically the
Mm-hmm.
previous context.
ChatGPT
So
will do because
ChatGPT will do.
it has a different memory system. I think we will teach that. You can learn it. It's very simple logic. It's just that you have to do two types of memory. One is a direct one, and another one is a semantic one. So because as the memory goes up, you cannot directly search to it, right? So you have to again use a vector database for it. So we'll get into that. I think in context engineering, we'll get into that. But you can go and read if you want it immediately if you're doing that work in company. Okay.
Yeah. Sir, a
Yeah, it will.
It's a
simple approach could also be in this case that you inside the system prompt you keep pushing up the messages that have been the chat that has already gone on. So the user prompt
that
and
is
the
not
system
for
response.
production grade system. Oh,
Yeah,
yeah,
But the
I
okay.
agree with
tokens
that, but
actually
that is
limit of tokens is there. I mean,
so
Yeah.
that is what
that's
I taught you last class one concept called n square. If you remember, time complexity of transformer is n square. You keep updating the history and send every history to the LLM. LLM will take square times. So you send one sentence, okay, it gives you two sentence response. Next time it you ask another sentence, so you have four sentences, correct? So you send the four sentence. I'm not talking about sentence; it's a paragraph ideally. So if you send all the four sentence to transformer, it will take 16 times the previous time, right? You understand what I'm saying?
Yeah, okay,
So
got it.
it will take a lot of time. So you are just, and that is why you have a context engineer. So that is for POCs, it is fine, but not for production grade solutions. For production grade solutions, you have to maintain a memory. There are many memory systems you can go. Inbuilt like libraries are also there. You can go and check for it. Okay. But we will see the concepts. Libraries are built over the concepts. If you understand the concept, you can build one library yourself. Okay. Mm, any other question? All done?
Oh, so one question I have, am I audible?
Mm-hmm.
Yeah, so actually, recently ChatGPT 5.1 and Gemini 3 have launched, so I was trying to
Mm-hmm.
use that. Main
Mm-hmm.
issue, what I faced was like when I give the prompt, the answer they give is usually very, very large, right? I mean,
Mm-hmm.
if you use a thinking model, like they will give you a very one page kind of a
Mm-hmm.
response. I
Mm-hmm.
mean, is there a way to customize the response? I mean, there are custom gems you can make, but at each prompt, right? Like,
Mm-hmm.
uh, what I'm trying to ask is like, is there a way which in which we can like customize these responses?
Mm-hmm. Yeah, of course. That is what I think partially you will see in today's class.
Okay.
By default, you will get that customized result. So even if it is thinking, if you wanted only one word answer, it will give you one word answer. But you should
But sir,
ask for it.
okay, so I have to, okay, in this class we will learn that, right?
Uh,
Okay. Yeah.
that's what I said, right?
Yeah, yeah.
So if you knock the door, it will open. You have to ask for it. So when you ask for it, it will surely give. But if you don't ask, if you ask only the question, it will give the complete answer. And thinking models, as you said, of course, it will think, right? So it has to give you a first, it will try to understand the question, then it will try to gather the answers, it will produce then it will aggregate all the answers, and then it will start generating the exact answer what you asked for. So thinking model you use for developing very robust like solutions. But when you wanted a very straightforward answer, like you give a sentence and ask it to give its positive or negative, the thinking model will do analysis of the sentence, why it is to be positive, why it is to be negative, and what is the reason for it, and finally how it found that it is a positive sentence. All these things it will give. So, but if you wanted just one word, positive or negative, then if you ask for it, it will give. And that's what we will do today also. We'll see. We are just ahead of the schedule. I'm already ahead
Uh,
of others. Yeah,
so
yeah.
one question. So to get the context, we use racks, knowledge base, and other techniques. Uh, so in a context like where we should use SFT kind of a technique of fine tuning, and what are the use cases where we should go to this knowledge graphs and racks kind of a setup.
Fine tuning versus knowledge graph. Is that the question?
Ye- Yeah, what is the use case of to get into this form, or should we go into that form of design?
Did you attend the previous section, a previous lecture, or I
Yes, sir.
think the previous to previous, I guess. I think the third lecture. Let me see. I think I discussed this in one of the lecture I discussed, but when it will come for fine tuning, then we will see that in detail. Detail nahi hai, the same thing I will tell you in a second. Again, I'll tell you the same thing. But it is you will get it. I think fine tuning has not been taught here. So I think sixth will be fine tuning. Correct. So next lecture will be fine tuning. So of course you will learn that. Okay. So you will understand what it can do. Fine tuning will not replace RAG. Understand? If somebody tells you that, don't believe that. Okay. So people may think that fine tuning means I have always heard this from my management. Okay. So they will come and tell that why are you making very complex solutions? Why don't we just take one LLM, train it on our data, and then deploy it? It's very simple, right? So of course it is very simple. It will not work, right? That is what you will learn. And I just told a funny sentence, funny scenario what I have encountered in company. Many people come because they think that LLM can learn, but LLM can learn not by fine tuning. It will learn from pre-training. I guess I taught right in this class only. I have discussed. I mentioned this right. LLM pre-training में सीखता है, ठीक है? It learns, but in fine tuning, it just optimizes the way it gives an output. So like a structured output, or a way it can deliver. See, you have a knowledge, okay? Like for example, take a person who read from 100 books, okay? So there are 100 books of knowledge he has, but when he joins a company, does he know how to deliver that? Uh, okay, coming to our own assignment. So point is, like we have to see, you are very intelligent person because you have read 100 books, okay? But if you do not know how to deliver it to another person who has never read that 100 books in 15 minutes, then there is no use of it's not no use, then that gap will be there, right? So, and that is what your fine tuning is doing. So pre-training makes you learn that 100 books. Fine tuning will make you deliver it in a presentation form. And same thing, you see, I can give a good presentation to my company anytime. Okay. But I am not very good in writing blobs. I don't write blobs. That's why many of my friends tell me write blobs or medium में ये लिखो. I do not know. Maybe nowadays we can use AI tools, but I'm not interested in that also because I am not that kind of guy. So because that is also one thing they say, like that is an art. So a person who has studied 100 books has the knowledge. That's the pre-training part. So now you can fine tune that person to give a very good presentation. The same knowledge he is going to put it as a presentation. Okay, the output, the way he want, the way the company wants. Okay, but same person you can also fine tune to create blobs. So maybe it is like a news media agency. So the same person goes there. So now you have to fine tune that person to deliver, make the person to write blobs, or you take the same person, fine tune him to deliver lectures like what I am doing, right? So this is the things. I hope I'm clear in this, right? So could you understand what I was trying to say?
Yeah, sir, I got it now. Yeah.
Okay. One more thing to add on to your question, which I didn't answer, I is that the rack part. So where does rack come here is like same example we'll take. The person has read 100 books. So he's very knowledgeful of what is there in the 100 books. So fine tuning is to make him deliver in a presentation form, make him deliver in a blob writing form, or make him deliver in a lecture, giving lectures in classes. Okay, that is all fine tune. But what is RAG is so you take me as that person whom we are talking about. Okay, so I have read 100 books, but when I read in 2023 about AI. Okay, but if you will ask me to make a presentation today on that subject, including this, right, in the slides, so will I be able to make a very good presentation? I am having an art of making a, so I have been fine-tuned to make a very good presentation. I will make a presentation, but my knowledge is limited to 2024, correct? But there are, so sorry, 2023. But there are a lot of advancements which happened in 2024 and 2025, correct? So what happens is all those knowledge, if I have to learn, again, I have to start reading the books, correct? Reading the books, blogs, everything. But what does that mean in the LLM term? You have to again go for pre-training of that LLM with all the new blobs, new books which came from 2023 onwards till today, correct? Which is very costly. It's possible, but it's very, very costly. Okay. So that is why we do RAG. RAG means suppose I am making a presentation on structured output. Okay. So LLM structured output and function calling. Okay. For this, I don't need to read every research paper out there in the world which came from 2023 to till today. Correct. I may have to read 2 research papers, 3 research papers, and 3 more blobs. Only 6 items I need to read, right? So for my company needs only a presentation for structured output and function calling. But if I tell them, no, 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 I have to go and read all the research papers from 2023 to 2025, and I will need some $20,000. No, 20,000 would be very less. Just 20,000 chhod do. Take some $1 lakh. 1 lakh. Oh, you reboot 1 lakh. Sorry. Okay. Where I was. Okay. $1 lakh if I ask for, then my company will throw me out, right? So what I should do? I cannot do a pre-training of the LLM. Instead, I have to only use a RAG system in which, okay, my intention is to prepare a presentation on this, right? So I will pull some 6 current recent papers, 3 papers and 3 blobs, and then put it to my knowledge. I will just read that quickly and then give immediate presentation. This is RAG. I hope I clarified. Is it very clear?
Yes, sir.
Do you think any more lecture is
Uh,
required to this explanation?
no, sir, it is very much
No,
clear.
right?
Thank you.
But again, I will repeat it. Others have to forgive me because
No,
anyway
no,
it will
I
come
just
later.
have a follow-up question.
Yeah, yeah,
So in case,
very
right,
good. Mm.
in our organization, let's say, right, you're
Mm-hmm.
talking about the 5 to 6 document, right? But there could be, let's say, 50 to 60 documents and with the different formats.
Mm-hmm.
So, and some other share points and all. So in that case, should we again go with the RAG kind of architecture, or we should model the data source in a like inbuilt model, or we should use pre-trained and then go with the RAG plus, like what should be the approach in this case? If we have basically we have to take all the company data to like the policy related and everything to.
Complete data you have to take that. I agree. But for a say, what is the final outcome? You have to see the final outcome, right? So you want to say there can be 2 ways. I will handle both the ways also. Like first case, you are going to build a querying system like chatbot or something. So your users are going to query on that particular database, correct? So this can
Yeah.
be a very for every query you have to run the RAG system. It's as simple as that. So you may have thousands of whatever you called the legal documents or whatever it is. It's like 1,000 legal documents in your company. Okay. But for a particular query, it can be only 2, 3 documents, right? You agree?
Yes. Yes. Yes.
Okay.
Yeah.
But there is another case. Another case is a different case. Like, for example, it can be a report. So one first case is like people are asking, okay, what is the clause of this? What is the particular legal clause for this purpose or this work or something like that? What is the checklist for this? All those are small queries, right? But there can be one more query, like for a particular project. Uh, it's not a query; it's a very big system. Like for example, for a particular project you are doing, get me all the legal clauses at the various stages of the project, right? So it's a very detailed question, and you have to go through at least some 30, 40 legal documents and then prepare it, correct? So that could be a one probable use case, which maybe you thought or you did think, but I can think. Okay. But point here is in such cases, of course, you cannot answer it in your chatbot. Okay. Because that requires 30 documents, but you do not need a uh, uh, pre-training. That's where we will go for agentic workflows. Okay. So agentic workflow is nothing but you have to go see as a human. Chod do, like you leave all LLM agent, all those stuff. As a human, if you are as I am assigning you, always see this is one thing I want to tell you guys also. Whenever you want to design an AI system, na, think if how a human will handle that. Don't think simply LLM can do anything. How a human will, like I told you about an example of a human learning from 100 books and how he is getting fine tuned to deliver a presentation. So keep all the examples correlate to a particular human, how he will learn, how he will do, how he will execute, okay, how he will analyze and then consider that human as an LLM. Okay. So how you will augment data, more data to him. So all these, if you can visualize, I don't know whether how many could think what I'm trying to, like how many could visualize what I'm trying to say. But if you do it, you'll prepare the best architecture possible. Okay. So you don't need to even ask anybody. So coming back to the same query, uh, so what we are, I forgot the query at all. Mm, where did I leave? Anybody can help me? Uh, okay, the analysis. Okay, so when there is an analysis, now you have to go and search every document in the world, not world, in your 1,000 legal documents, and then find the relevant clauses, bring it to the table, and then try to prepare section wise, right? Section wise means you have to prepare a very big report for your particular project, various stages. Like first break your project into various stages. Like your project has suppose 20 steps. So every step, so this or everything your agent will do. Okay, so you nominate an agent first to break your project into 20 steps. And for every step, go to your legal documents, which is 1,000 documents. Go and search in each of the document and find the relevant clauses, come and consolidate and put it on the first task. So this is called subtask generation. Okay. So this happens in the agentic workflows. I hope you understand. So when a detailed analysis is required, you implement agents. You don't go for pre-training because pre-training is, mm, yeah, I don't know if you are from OpenAI or Gemini, yes, it is possible, but otherwise it is a very costly affair, right? So, and also it is not worth that. So why it is not worth this? Nobody does pre-training of a particular domain. Understand? Until it is going to be useful for so like millions and millions of people. Like for example, why do OpenAI or Gemini or somebody pre-trains is because that LLM we can use anywhere, correct? But you don't pre-train a LLM for a particular sub 1,000 documents, 2,000 documents. Understand? Because that's wastage of money because you will never get to ROI, right? Until maybe the hardware becomes very cheap in later in life, then you can do. But why even then even though you do pre-training, again you have to apply the rack technique for getting the correct answers. Because whatever you are learning happens during pre-training, it learns only the structure of the content. Okay, so it's like a person who has learned mechanical engineering, uh, like even if he talks to his wife or his parents, you will see his education in it, right? The style in it. So you will find it. If he doesn't talk, then he didn't read properly. But point is, not only studying BTech I'm talking about. When you work 20 years in your company, like in fact, if you see a very good coding people, they will talk also in that language. Like they will say, "Arey, we'll set up a pipeline for this." Normal talk. It's not related to code, but still we will talk about like pipelines. So that is the language what the LLM is learning. It's a language what it learned, and some knowledge is going into it. But the most accurate answer you will get only by implementing RAG. You will never get only by pre-training. Okay, so you should implement RAG even though you have pre-trained on that same data. Okay, so that's how you get an accurate answer because it may not remember each and everything, right? So it depends on how big is your LLM. If you understand the neurons logic, you will never learn everything. Oops, 1 hour okay, okay, no problem. Okay, I hope I answered your question also.
Yes, sir.
Did I answer? Yeah. Okay.
So
Good.
just one thing, I think some of the part was left in the last session slide also.
I segment. I thought
Yeah,
I
I
completed.
think you marked there. We covered up to LoRa, right? Low rank, and then afterwards,
Let me open and forgot.
I think I put a cross there to cover it in the next session.
Oops, I not covered some part. Hmm. This one, huh?
Yeah,
Okay.
yeah,
So LoRa, though I explained last week, right?
yeah.
So any
That's right.
doubts on LoRa? The same thing only I already explained actually at this place only. So if any doubts, I can explain more. So this also I explained already, but one thing what I wanted to say here is about this quantization part. Okay, the quantization is is there any diagram? Oh, my diagram is not there. Okay, no problem. Quantization Q LoRa means you can see this four boxes, right? So this is the input. Okay, this is the main LLM weights. Okay, so these are all the weights. And for LoRa, what you do, you create a low rank matrix. Okay, of these weights, and then you only fine tune these. Like if you remember, I was talking about I think 4,000, if I remember correctly. If the main weights are like 4,000 by 4,000, these many number of weights were there. Okay. So in the main LLM, pre-trained LLM. Okay. But when you are fine tuning, you cannot fine tune all these 16 million parameters. It will take huge memory. Okay. So to fine tune in smaller hardware, what you do, you create a see, and another thing, first of all, you don't need require to fine tune everything also. Why? Because you should not all why because this that if it changes so much, if the original weights, whatever is, suppose you take one weight, W is equal to zero point 0.1. Just for an example, I'm taking one weight. Okay. So if you take this is a zero point 0.1, it will not be point. Let me write a bigger 0.125326. Okay. So suppose this is the number, you should not change this also. Like for example, when fine tuning, okay, this becomes 1253. This is a huge change for this. You should not do this. Okay. You can only change very less. Like for example, only this number or this number, two numbers. So after fine tuning, it can only become 0.1253, maybe 0.2. Instead of 2.6, it has become 0.2. Only very minimal change you have to do. Why? Because till now what we were discussing also is related. So during LLM pre-training, okay. So what it learns is the language structure, right? How it talks in a but. So it learned the language structure during the pre-training process, like how to frame a sentence, what is English, how do you talk in English, how do you write in English, all those things, the structure, syntactic nature of English, grammar, all those things it learned. Okay. So if you change this so much like here, it will forget that. You don't want it to forget that. So it's like you are taking a somebody from college, like take our my own life itself. So I studied mechanical engineering in BTech. So then I went to R&D, then I came to data science. So last 12 years I'm working in data science. If you come and ask me, okay, you ask me some law, right? Ohm's law or any law, whatever I forgot. There is one more law, famous law. If you ask me that, I don't remember that. Even I don't
Hooke's law, sir.
remember the
Yeah.
name, right? What?
Hooke's law.
Hooke's law. Yes, yes, yeah, correct. Hooke's law. I will not write here, but Hooke's law. Yes, this is a very famous law, right? This is a very simplest question they ask. Okay. I don't know. Bernoulli's theorem. Yes, I cannot exactly say I can give you an idea about it, but I do not know if you want me to teach. So point is that was my core foundation, but I have been fine tuned so much now that my mechanical engineering knowledge has gone, right? So it is like that, right? So another thing is like actually more suiting to this example is language learning. Like you can see people who have studied in India, right? So they have like consider a Hindi speaking guy. He has a very good like speaking sense in Hindi, right? So he knows to speak very nice Hindi. But if you will take him to US and make him sit there for the next 20-25 years, he will forget the majority of the Hindi words until he speaks in his home. There is a case that okay, he and his wife speak in Hindi, but they consider that nobody is there to speak in English. He married an American, so he settled there. He never speaks in Hindi. When he comes back, he will horribly speak Hindi, right? So that is what exactly is happening when you will change the weight so much. Okay, so you should not change. You should only fine tune him into a American guy, but not from the core culture and the language should be grounded, rooted here, right? That is what we are doing it in the fine tune. We should never go away. That we will learn in the next class, but I just wanted to tell you here because you will appreciate why we are going for this also. So since we are not going to change this frozen weight so much, the pre-trained weight so much, it is good to go this instead of training, even though fine tuning this for a very less, very smaller number. Instead of that, you can better go for this. You should be able to appreciate that. Okay, so that is first point. Second point is we are not using 4000 by 4000. Instead, we are doing 4000. That is the D value. This R is the low rank. So that is what LoRa. Okay, low rank adaptation. Okay, so R is typically like 4 to 64. Okay, so maybe you consider like 8. Okay, so here also it is 8 into 4000. So you had a matrix of 4000 cross 4000, but you are making that matrix using two smaller matrix. So if you see, this is 32,000 numbers only. Okay, so you are ideally fine tuning 32,000 plus 32,000, which is around 64,000 parameters only. So that is how the load on your hardware decreases. But in real life, if you would have fine tuned this, it is around 16 million, correct? Three zeros and 16, 4 into 4, 16, correct? So instead of 16 million parameters fine tuning, I'm just fine tuning 64,000. And what I will do, I will multiply these two, do the multiplication, matrix multiplication. When you do 4,000 cross 8 into 4,000 cross 8, 4,000, you will get a, when you do a multiplication, you will actually get a 4,000 into 4,000 matrix. And this matrix is your fine-tuned part. This is called delta W. Okay, this part. This, when you multiply this, delta W is equal to A dot B. Okay, I think that will be written in the previous slide. Delta W is equal to B dot E. Okay, or low A dot. And the final new matrix is the, the original 4,000 cross 4,000 plus this delta W, which means this delta W is very, very low numbers, right? So it is like, it will be like this. You understand? This is one number, right? So this is the original number, 1, 2, 5, 3, 2, 6. Okay. This is your sum W1. Okay. So your delta W1 corresponding to that will be like 0.00024, and it will be minus here, equal to minus 0. This one. So now if you add these two, you will get the W new. Okay. So that is this value, this value. Okay. This is minus. Okay. So if you add these two, pardon?
How this low rank, the number 8 is coming, like, is there any formula or again some algorithm, or is just a random?
It's again a random number. It's not random number. You decide based on your architecture. Of course, right? So if you put 4, it will be more lesser and very less fine tuning happens. If you want to do like more fine tuning and more data is there, you can go for a higher number. Okay. And you will evaluate it. It's not like randomly you will fine tune and then use it. So you, while fine tuning, you will evaluate the system also, right? So you have some same way, like in your ML, you had 90% data for your fine tuning and 10% data for your testing purpose. So you'll get a metric, right? So what happens is first time you use R is equal to 4, train it and then get a metric. And next time you put R is equal to 8 and then train and get a metric, because nobody can confirm you, okay, 8 is the best one. It depends on the model size. It depends on how much data you have. What is the quality of the data? So when the quality comes, nobody in the world can tell you that this quality is the best quality. There can always be a better quality or there cannot be also, because it is all unstructured data, right? So nobody can tell you which is the best quality data. So you have to do the trial run from 4 to 64, 4, 8, 16, 32, and 64. 5 numbers only, right? So you can run the algorithm and then understand. Okay. And another thing is hardware also. So 64, if you go, that more number of parameters will be there. The 8 itself, you are getting 64,000. So 64 means it will be more than that, right? So of course, into 8 times ho jayega. So whether your hardware is able to handle that, that also we have to see. Got it?
So how much time usually it takes? And I mean,
Again, depends on your hardware now. If you have a very good hardware, very big hardware, then it will be faster. If you have a very small hardware, it will be slow. And if you can parallelize things, it will be more fast. If you have like parallel computing GPU, you can do parallel computing also because of your attention layers are independent of each other, right? So you can do a parallel computing. So if you do all those things, it will be faster.
okay.
So it again depends on if you have laptop, exactly laptop, it will take, I guess, minimum hardware required, you can calculate. I guess there will be a session for, I don't know whether it will be here or in MLOps. I'll check that. Okay. So we are not worried about the hardware here. So time, it should not take much if you use QLoRa. It will take some 3 to 4 hours. Again, it depends on lot number of things, right? So it depends on LLM size, right? The original parameter, number of parameters, right? 4000 by 4000. Then the quality of quality name, data, how much data you have, right? It depends on that. Then what else? LLM size, the quantity, and the hardware, right? It depends on these. By this, you can tell how much latency you have. And quality, for quality of whether that fine tuning is enough or not, for that then this R value is required. The rank value is required for quality. This is for latency I'm talking about. For quality, you will require many more things. So quality, you may not require this, but this will be dependent. What is the current LLM size? It depends on that quality of fine-tuned material. So hardware will not be related, but data quality will be important. Correct, data quality, and then how much you fine tune also, it depends, right? How many epochs you run. So you can run few epochs, and people run 5 epochs also. You can run 100 epochs also. It depends on you, right? So if you fine tune more and more, it may, but ensure that you apply it also depends on what is the algorithm you put. Okay. So algorithm also. We'll see the algorithms next class. Epochs, it depends on you. Data quality depends on your data quality, what you have, right? And LLM size, whichever you select, depends on that. And LLM size, apart from that, LLM's quality also. Like for example, the same size, but quality may be already different because the pre-trained quality also differs, right? So if that is why I told, I think in the previous class I mentioned that. So when you are taking a LLM for fine tuning, ensure that uh, it is good to ensure that your LLM was already pre-trained related to your original data. So this data, what we are going to do fine tuning is your domain data, like for example, legal data, for example. Okay. So if your original this pre-trained LLM was also trained on some of the legal documents, may not be your company's document, but it is an open general document, then you should prefer that LLM. So there is two LLMs in this case. So this LLM was never pre-trained on legal documents, but this LLM was pre-trained. So then you should prefer to fine tune this LLM rather than this LLM. Okay. So that LLM size and quality is also important for final quality of your pre-trained model. Okay. Did I answer your question? No? Okay.
Yes, sir. Yeah, yeah.
Okay.
So
Okay.
one question
Coming.
I have, sorry. I mean,
Yeah.
sir, we are fine tuning, right? But we can also use a RAG for this legal documents, right? Again, like
Mhm.
it depends on the. I mean, we can achieve similar things by using both the approaches, right? We are fine tuning to have a specific structure, right?
No.
As I
Right.
understood. No?
No. You can see, that's what I told you. You can do fine tuning if it is cost effective. Okay. But it is not guaranteed that, see, why RAG we are going, I told you, right? Okay, we will go to the RAG and then discuss that. Okay, don't worry now. I'll have to again repeat what I said. Okay, do you want me to explain that? Today's class is important, right? So we'll go through this and then we'll see that later. Okay, okay,
Okay, sir,
no
sure,
problem.
sure. Yeah,
Okay.
yeah, no problem, sir.
So, okay. So coming back here to the same thing. So LoRa we understood, right? So we have this, we have this. But in LoRa, what we do while fine tuning, even this is less number of parameters, which is only 64,000. But point is, we are going to use FP32 for the fine tuning. FP32 quantization. Okay. So the data is going to be at floating point 32. Okay. So that will again will be overhead for, not overhead. That is the correct thing. That is how you get this many number of decimals. I agree with that. But point is, can you reduce the load on the hardware? So now maybe uh, if you wanted to fine tune the complete weight, you require maybe 5, 6 GPUs, for example. Okay. So using this LoRa technique, instead of fine tuning this full weights, I'm just fine tuning only 64,000 weights. Okay. So in this case, I may need 2 GPUs. Okay. So now somebody else thinking, okay, can I use only one GPU or only my RAM for doing this, CPU for doing this? Can I do it? Yes, you can do it. Okay. But of course, your efficiency will go down, but not much. That's what I, not, it is not much. There will be an effect, but you will, if it is okay, then you can go for this. Okay. That's the point. So it's a, this is also possible. This is QLoRa. What is QLoRa is quantization over LoRa. Okay, we saw what is LoRa. That's simple. Okay, now we are just only one thing is quantization. Quantization means the base model we are keeping it 4-bit. Okay, and LoRa adapters we are keeping it at FP16. Okay, so what happens is in this your original model is only at 4-bit, right? So you are have need to have only very few memory is requirement is very less. Okay, that's the point here. And memory saving is 70 billion model single GPU. That's what I told you, right? LoRa can be done on uh, 2 GPU, and maybe this, if you do QLoRa, you can do it on 1 GPU itself. In fact, you can do it on CPU itself. If you will quantize to this also, if you reduced it, then it will be very less. Okay, that's the only point. So quantization we have already seen, LoRa we have already seen. This is just that you are quantizing the thing before doing the training, fine tuning. So it's just that all the memory requirement will be very less. Okay. So if you see, this is what is training from scratch. We use FP32, right? That's what I told you, if you remember. Stability during gradient updates. You cannot do pre-training. This training from scratch means pre-training. Okay. So remember that. This is what we have been pre-trained. Okay. So pre-training is for stability. You cannot do it on very low quantization. You have to go for this or BF16. Okay. And fine tuning, you best to go with QLoRa. Okay. So best means memory efficiency, good quality, not very good quality. Okay. So that's all. So, and then finally production inference, like once you fine tune the model. So this is the pre-trained model, you pull it and you will do fine tuning. And after you fine tune, you will deploy it for production inference. Okay. So during inferencing, you convert it back to BF16 and then deploy it. So it will be like good for speed and quality. Okay. So edge deployment means in your, in any mobile or any hardware, like car, you want to put it in a car dashboard or anywhere else, like in mobile or watch. If you want to deploy, then further optimize it. So only deploy model of N4, normal float 4 bits. Okay, minimal memory footprint. Okay. So real-time application, you can go for like to get a very high speed. Like in chatbots, you wanted a very high speed, you can go for this. But all these comes with some amount of sacrifice in your quality. Okay, but not so much. It's acceptable. Like for example, if you say that mm, this is okay, this is one BF16. Okay, BF16 is the production normal. That is how the original one was pre-trained. Okay, so if you deploy it same way, maybe it is 98% accurate. Okay, so this will be around 94% or 93%. It's still fine, right? So this will be 92%. So this is still fine, right? So not so much difference, but you will not get correct answer. But that is why your requirement also you should reduce. So you understand? I'm not giving because this is not exact numbers. So it exact numbers depends on what data you have used. Okay. So that's the point. Uh,
So QLoRa
memory
is
foot.
only for like LLMs or SLMs also we can use QLoRa on.
No, no. LLM, SLM, कुछ नहीं होता है. Both are LLMs. I don't say LLM is just a large language model. It is all for language models. So whatever we are discussing is for language models. Okay. So we normally call it as LLMs, but it is not. It is not small or big. What we are talking is language models. Okay. It applies for everything, small, large, medium, everywhere. Okay. So it's all this. All these are talk. We are talking about language models. Understood, right?
Yes, sir.
Okay. Okay. GPU memory. This you can go through. Okay. This we have discussed. You can just go through. KV cache. I guess this is the calculation. You can again go through. So if you understood, we have discussed this, right? So without KV cache, it will be like O n square, and with KV cache, you can decrease the computation to n. But this will not be possible everywhere. It depends on the architecture of your transformer also. Okay. So this they will already do it in most of the transformer nowadays. Everywhere they are doing. There is no recalculation of the sum of the keys. This you don't need to worry because it is part of the inference itself. If you are just querying on an LLM, it will already have. You don't need to do until you are pulling a small LLM into your small LLM near the small language model, small language model into your laptop. Then you have to think of all these things. But there is just it's just that you have to say that KV cache should be stored so that it doesn't query on it. It will don't calculate the, it doesn't compute this Q1, K1, all these things again. Okay. So if you see for every new token, query here means tokens. Okay. So every new token, only this you will store it because for the new token Q2, this is Q1, this is Q2. For Q2, you don't need to calculate these two if because of this n square logic. If you understood the attention mechanism, what you learned in deep learning last course, you will calculate these things again and again for every new token, right? So you don't need to calculate that because you would have already calculated that with the from the previous step. You understood this, right? So anybody didn't understand this? Want me to explain that more? If you're silent, then I will go to the next slide. Okay, nobody is. Understood. Thanks. Okay, KV cache, the hidden memory consumer. Oh, these are all calculations. You can just go through. So now you can see memory. It's nothing to teach here. Okay. So these are all some of the techniques during if you are deploying your own LLM. Okay. So if you're querying to GPT or using an API calls, then these are all not applicable. This is what we were talking about, right? So flash memory, flash memory, paged attention. You just understand that what is what. Okay. That is parallelism and pipeline parallelism. Okay. So what is parallelism? Anybody can understand this from here? There it is already very clear here. What is parallelism strategy? Oh, sorry. What is tensor parallelism? Do you understand this sentence? Split layers across GPUs.
Yes, sir.
Okay, you understood, right? So that is the MLOps logic. So if you have a very big LLM, so I'll just explain. So if you take the input and then you have suppose 100 layers before it gives, because these are all decoders, right? So which we discussed in the lecture 2. Okay, so this is your output. And finally, this is your output. Okay. So you don't need to run all the things in one like one GPU, right? So in every GPU, you don't need to run. Apart from like having this pipeline parallelism, you can also split that into GPUs. Why? What? How is it useful? Is like, for example, first GPU, GPU 1. and then you consider GPU 2, and then you give an output. So what is an advantage of this? Can somebody tell what is the advantage of having the first 50 layers in this GPU and second 50 layers in here? Can somebody say?
Multiprocessing.
Yeah, training in the parallel, so it will save the time and
No, training chod do. I'm talking about inferencing part. What could be the advantage here? Actually, it is not 2. If you consider 4 also, doesn't matter. Each 25. Tell me.
So, so
Yeah.
you can have the weights for each of the layers in the GPU memory. One GPU memory probably can have for layer one and the other one for the layer two. So the inferencing will be faster because we don't need to uh, fetch the weights and the inputs again and again kind of thing.
Mm,
Uh,
not exactly. Somebody else
One more.
want to try? Yeah.
Yeah. So, so GPU once well inferred data or extracted data will be the so GPU once output of well inferred data and output will be the input to the GPU too. So it will ultimate output will be with fine tune. I mean, well
No,
groomed
no,
and all
no.
that.
You guys are thinking in a transformer base. See, this is the complete one LLM. Okay. Don't break the LLM. It's the output of the LLM is here only. It's between this, it is only the tensors. Tensors means vectors are going. Decoder will produce vectors, right? So the vectors, one decoder will produce one vector. It sends to other decoder to enhance it. Another decoder, like this. It's just that this decoder, I am just breaking, I am using all these into one GPU, and this tensor, whatever is generating here, I am putting it in the another GPU. Okay, there is no output, valuable output here. It is just an vector, and I'm not interested in that vector also. So there is some concept called software pipelining. If you guys know, uh, that is why we go for this. That's why I don't wanted to teach here all these techniques. Every technique is one course, not one course, one lecture actually. So that's why I told you, you just go through this. Simply know the names of this. I'm not going to ask you what is it in the exam, because it is itself one lecture. Okay. I am myself taking it on another course. This is one lecture. This is one lecture. I'll tell you in a very quick way what is software pipelining is. You will understand. For example, instead of 2 also is fine. So I will write as G1 and G2. Okay. So what we do is we take one input here. Okay. So we give, so you understand that logic, right? That your transformer first prompt, if you give, it will produce one token. It is not output. It will produce one token. You agree with this? So prompt is a set of tokens, right? So T1 to T10. For example, 10 tokens were there in your prompt and it produced 11th token. You agree with this, everyone?
Yes.
Correct? So what you do, you don't see, but when you query, when you send a prompt to LLM, a GPU or anything, okay, what does it? It gives you only one token, one word. No, it gives you keep on giving you tokens, right? It streams you response. It gives you a big paragraph, right? So how does that happen? But LLMs are capable of producing only the next word. Token means just one word it will produce. Okay. But what we do is inside what the API creators do is they take this prompt. So I will not write one for the prompt. P is my prompt. Okay. Prompt means consider first 10 tokens. Okay. P plus the 11th token. And then I send it to the same LLM, the same LLM. Okay. LLM or language model. I call it as LLM. Forgive me for that. Take it consider it as a language model. It is small LLM or a small language model or large language model, doesn't matter. Okay. So to produce next token, that is why in your chatbot response, you will find like it is typing the answer. It is not giving one, simply it is not displaying the complete paragraph. It is typing. It will look like typing, right? Why? Because it is producing also like that. It's not like that for decoration purpose. They have done it in your chat. So after this, what they will do, they will give P plus P T11 plus T12, send it to the same LLM only. Okay. So you will produce T13 like this till this token, whatever token may be nth token production. Okay. When it produces the nth token as the end. So if this nth token is equal to end, for example, end. Okay. Last word. Differs for each LLM. Consider that if it says end, then I stop. That is my all the paragraph. So for Gemini, if you see, it will produce around 200 tokens, and then finally it will produce the end. For example, one of our friend was asking like, thinking model produces bigger answer, lengthier answer, right? So means it is producing 1,000 tokens before it produces the token as end. So when the end token comes, which means it is not useful to send it back again and then add with T11, T12 like this, and then T end also. End token, you don't need to send it to your LLM because it has produced, it is the end. You don't need to send it back. Understand? So it's just an programmatically they do this. Okay. So if you understood this, then you can understand this also. Okay, what does we do here is, and what is software pipeline? Software pipelining is, so once you have the prompt here, okay, so what happens? I'll do it in at time one. Okay, again, time is T now. Okay, time one. So P is sent inside. The prompt is sent to G1. Okay, at time two, I say that this has produced some vector. Okay, this is not sent to you. Okay, only this output is sent to you. So now at time two, V1 will be sent to G2. Okay. Now if you see G1 is ideally sitting, there is nobody using G1 because now at time two, V1 is sent to G2 and G2 is producing the token 11. Agreed? Now at time three. Okay. So now you have T11 you have and prompt you have. Now what you will do, you will attach this P with 11 and send it to G1. Correct? You can send it to G1. Now what you see, G2 is sitting ideal, is not doing anything. So here G1 is sitting ideal, G2 is sitting ideal. Okay. But at time 4 comes your point. At time 4, what you can do is you can am I missing something? Hmm. You can send this. Oh, I'm missing something. Wait. This will produce V2. Okay, correct. And then V2 you send it here to produce V3. And in parallel, you can do no, not this process. I'm a bit stuck.
Probably a new prompt, P2.
No, not
So
a
that
prompt. It will not be a prompt actually. It will be and you can correct. Yes. Yeah, you're right. Correct. Sorry. Yes, you are right. What happens is thanks for your guidance. So this is a prompt one. Okay, this is prompt one and this is prompt one. So when this is idle, right? So since your prompt one, this is suppose from user one. Okay, so this is some user in India. Okay, but there will be a user two in US or somewhere else who sent his prompt, right? You call it as prompt two, right? So maybe at time T2. So it will see that G1 is not being used here, right, by P1. So it is free. So P2 will be sent here. Okay. This is correct. I just missed it. Sorry. I was like bit pipeline parallelism. Okay. So this is where G1 is sent here because this was not used by P1, correct? So this will produce V1 of P2. Okay, this is P2's V1. This V1 is coming from P1. Okay, this V2 is V1 is coming for P2. Okay, so this one in this case, if you see, this is also free, correct? This is also free. So I will write it in a different color. So this V1 is P2 ka V1. Okay, so now you can send V2 to here, and then it will produce the token T11, which is of P2. So in this same time, this P1 of T11 is going and producing V2. Okay. So at T4, it will be again same logic. Okay. So now you are like using two GPUs to ensure that parallelly you are processing the requests. Okay. This is optimization in perspective of a LLM calls. This is done by the LLM API providers. Okay, so that they can query your, they can send your results quicker. Okay, so that's why maybe one GPU here we were talking about only GPU 1 and GPU 2. Really, it will be like 4 layers in one GPU, something like that. Okay, so that you can make a very nice pipeline. So there are some logics like so even in Python, there are some things you can use to pool it automatically. It is pooled automatically. Okay, so whichever GPUs pending. So again, now there will be another one guy from somewhere else. We will take this. So user 3, and then he will send a prompt. So if only two GPUs are there, everything will be busy, right? So, but if you have some 100 GPUs in this 100 layers, just hypothetically saying, not 100 GPU, 20 GPUs. So per GPU, there are 5 layers. Okay. So in that case, you can process this guy also. Somewhere it will be free, some GPU. Okay. So that's the point. Thanks for the guidance. I missed it. Okay. So same way here, what is the pipeline parallelism is? So inside every layers, right? So if you take transformer, so this is we are talking about breaking the layers. But inside a layer, if this is the layer, there are different attention heads. If you remember, every transformer has multi-attention heads, right? So each attention head can be put in a GPU. Okay, so that is called splitting depthwise. So each attention head will be put in 1 GB. So all these are used for inferencing optimization. Okay, so very big LLMs are mostly done like this way so that you are, this is not for preparing RAG or architecture. That's why I didn't go in deep. But all these are, like if you have a very small LLM, maybe 20 layers, even that you can, if you want, you can break it. So these are all some ways you can break your LLM or SLMs into different layers and put in GPUs. But point is you have to write a wrapper around it. Okay. So schedule your queries like this. Okay. So that is the little bit difficult task, but it is possible. Okay. You can break it, and then when you are having multi-user systems, that is useful when you break it. Okay. A lot of queries coming in, then it is useful. Okay. Got it? Understood these two concepts?
Sir, within the single prompt, the generation
Ah,
of output is sequential only, right?
within
The
a
entire
single
output,
prompt. Yes. So that
the
is
entire,
sequential. That is, if you see here,
yeah,
P1 goes to V1 and V1 has to produce T11. And
yeah,
then P1 when T11 will come and then go to G1.
yeah.
This is single prompt. Blue color is single prompt, but red color is another prompt. Correct.
So at the end of the day, the generation part is still sequential. You cannot
No,
parallelize
that
it.
is where this pipeline parallelism comes, right? The pipeline parallelism will break your individual inside one layer. There are different
Yeah.
multi-head attentions, right?
Yeah.
So that you can put it in different GPUs and make it faster. Because at the end you are concatenating it, right? So you're not even doing any processing between this GPU and this attention head and this attention head. You agree with that?
I agree that, but that is encoder process, right? Not decoder one.
Decoder. Yes, decoder process. There you are
Okay.
parallelizing, right? So that is inside one single prompt only, right?
Okay.
You understand? So
Yeah, yeah.
that is how people
Multi-head
make it
attention.
faster.
Yeah,
Ah,
multi-head attention is parallel, but the output generation, because the output is coming in a structured, in a sequential manner.
hmm,
It is example, it has three paragraphs.
hmm,
The paragraphs are also aligned in a sequence.
hmm.
So it should be sequential, right?
That is sequential. That's what we discussed here.
Yeah.
But for a prompt, you can parallelize that, right? Pipeline parallelism. Depth-wise parallelism is possible, right? You understood that.
I understood
Multi-head
the depth-wise
attention is
parallelism for
parallelized.
multiple user prompts are handled by ideal GPUs. Like
Tensor
T1 and T2.
parallelism, listen
Yeah.
here. Tensor parallelism is not possible for a particular prompt.
Yeah.
Okay.
Okay.
Pipeline parallelism is possible for a particular prompt.
Okay.
Got it?
Yeah.
Are we clear here?
Yeah. Yeah.
Okay. You agree?
Yeah.
Because what your statement was, parallelism is not possible for a particular prompt. That's why I wanted to clarify that.
Yeah.
Pipeline parallelism is possible for a particular prompt. Tensor parallelism is not possible for a particular prompt, but multiple prompts, it is possible. For multi-user facility or multiple prompts, it's possible. Okay,
Okay.
correct.
Okay. Yeah.
Agreed, right?
Yes.
Okay, so this is just a table. Prompt caching, you can do this. Okay, so this also we will see it in the context engineering. But what we are talking about is caching the static prompt. Okay, so there is a very easy way of caching the prompt. So it's just like context engineering, right? You just have to you don't need to worry about the frequently asked queries. That is one part. Second part is the static content is there, right? So you can also vectorize when you have prompt, when you see, like for example, there is an input. Okay. So in the input, there are two parts, like static content and there is a dynamic content. Okay. So you will do the embedding of this, you will create a vector. Here you will do an embedding of this, you will create a vector, and this is what goes into the transformer, right? So if you do caching of this static part, which is you already know, right? So you can have this part as constant. There will be a time lag between this, right? So you can save it there. Okay, that is one example. Another thing is when this get processed inside the transformer, again, if I wanted to break the transformer into different layers, okay. So when it processed through the layers, it will produce some uh, vectors, right? So if this, but this you have to do it carefully when you want to design it. So you cannot simply take this vector and store it because it depends on the dynamic content also. Because when it goes along with these two will get merged inside, correct? So that is the context understanding. So you cannot store this vector, but you can always store this vector. This vector you can store. Okay, this vector is the just a direct conversion of this static content into this vector. So you can store this vector. Another thing is repeated queries. So repeated queries is like repeated context or repeated queries you can call. So when your query is sent and then you got the answers, right? So you can store that that thing in your memory. So that again, if the user asks the same query, you don't need to go and use the complete LLM process to get the output. If you store the, suppose this is the input, this is the output. So once this is the input and output, I store it in my cache. Okay. I store it like this. So next time the user asks the same query, so I don't need to go here and do everything. You just go here, get the output, and then send it to the cache, send it to the user. Okay. So most of them you will like, uh, you see, like after some 2-3 months, most of your queries will be same from the users, right? So only thing is you have to update your cache with this output. Output also you can update it. Like for example, why I'm saying what I'm talking about here is, for example, today I asked what happened in India yesterday. That's a query, right? So that query, there was an answer. Like there were some 5 events which happened in India. But tomorrow, if I ask the same question, can I bring that old answer to the user? No, right? For today, it should be a different answer. But you can calculate that answer at the back end and keep it ready for the user to, whenever the user will ask the query, you can calculate that answer and then store it in the same place. So that today, if somebody asks the same query, you just have to pull it from here. You don't need to calculate it in real time. So real time latencies, you can handle it there like that. You understood this point? Anybody?
Yes, sir.
Understood, right? So, but so simple is simply store the queries. Okay. So like you you get one query, you get the answer. So simply storing this. So you get another query, you generate the answer and then store it. So all the queries go through the LLM, sorry, language model, and then produce the answer. Okay. So first query you got, you sent, you got the answer, store it in your memory. Okay. So second query you sent, you got the answer and you store it here. But point is it will not be constant ever, right? So if tomorrow you come and ask the same query, it may not be this answer, but you can at the back end you can update this because you already know the query, you can update it. So most of the users ask the same queries, right? So humans are very limited also, right? So if you can maintain this memory in real time, this generation, not in LLM, your chatbot. So that is why it comes chatbot. Okay. So inside this chatbot, there is a this LLM. This is language model, but there is a huge part is the memory. Okay. So your query you sent, it's not always you send it to LLM and get and reply. Okay. So if you check the memory, if memory has the answer, you immediately send. So the latency is maybe milliseconds, right? So if LLM means it will take some 2 to 3 seconds. So you can save time in this. Okay. So this we will see in the memory context engineering also, how to prepare the memory. But the point here, what is made is if you do a caching, you can save a lot of memory. Okay. And these are all some emerging trends. You can just go and read through. These are all advanced technologies, okay, as on date. Okay, so I just put it here because you guys should be aware, because when you go out of this course, you should not talk about something uh, 10 years before, right? So most of this, in fact, I have also graduated from MTech. Many of things are outdated until you put in your energy and learn something. But these things I put it. Don't worry, this will not be in exams. But I'll not say this will explanations will not be in exam. But of course, yeah, emerging trends names you should at least remember. Okay. So I'll not ask these explanations because it will be very time consuming. I've told mentioned this to other faculties also, but if they're explaining, that is good. You can learn it, but it is not required. Okay. Okay, so I think this over. I'll go back to the fifth one. Fifth one is easy. Okay, so why it is easy is only two things: structured output and function calling. Okay, so we have 20 minutes. We'll do one thing. We'll go through the code. Okay, so we have the code. Mm, hmm. Okay, so I'll first show this Gemini one. Okay, so this combines both. If you understand this code, the lecture itself is not required. Okay, so what is it is you are calling a language model. Okay, so yes, I'll tell you. Okay, in brief, I'll tell you. So you are calling a language model. So when you call a language model, you will get a very big answer. Like one of our student was also mentioning that it will be a very lengthy answer, right? How do you get a structured answer so that you can process the output further, right? So in this case, what we are dealing is, we'll directly go to the question. I can run also. Mm, mm. So this is the question. Like you see, what's the weather in Paris today? Okay, so if this is the question, you're see till now what we learned. So we are querying a LLM, right? So LLM will not know. LLM means language model. Why I say LLM? Uh, we are querying to a, we are sending this query to a language model. Do you, can language model give a reply correct answer to this? No, right? Because the language model was pre-trained and fine-tuned on a past data. But what question I'm asking is today's weather, correct? So it will never be able to give the answer until and otherwise it's a chat bot. But when you go to a Gemini and then ask that question, okay, it will be able to answer this question because Gemini is not a chatbot. Okay. Hmm. So if I go and ask here, basically put it like this. Okay. So it will give a correct answer. Why? Because it is not using only the LLM. So that is what I explained here. If you remember on the previous, this one, Gemini is the chatbot. Okay. So you understand, right? So Gemini is the complete box, this box. And inside Gemini, this LLM, what they have is a very small portion. They have memory here. Okay, let me rewrite in another box. Is there space? Oh, let me see. All these slides, so much is there. I think last. Oops, thank you slide I did not kept. Okay, I will write here. So what is the point I'm telling is, so when you have a chatbot like this, okay, this is the chatbot or conversational AI system. Okay, chatbot. This is your query. What you send it to the chatbot is Gemini app. Okay, or your Chat GPT. Okay, oops, so much glaring red color. Or perplexity, all those things. Okay, so if you see here, you send a query. There is a small part is your language model. Okay, and there is a huge part is memory. All the memory we'll discuss. Okay, later. And there is a tools. Okay, tools. Like for example, this is a web search. There is a tool for maybe some other database search or something. Okay, whatever it is, or it is a graph DB search. So your query is, there is a complete workflow here. Okay, so that is what we are learning. We are not learning only about LLM. LLM we cannot do anything because that is already taken. So this language model is pre-trained plus fine-tuned. And this memory, this one, this one, this one, all these belong to the RAG concepts. So because the LLM will generate the answer. Okay, so LLM finally can generate the answer. It's not mandatory that it has to come for the answer should come from there. I will put it from here only. This is the answer. Okay. It can come from here directly, or it can go, this LLM can tell that, okay, go to the graph database and then pick something and then directly send the answer to the user. Okay. So there are multiple probabilities. It's not like that final point is also only LLM. Okay. You understood this, right? So now going back to this point. So if you see here, Gemini LLM, this whatever is the LLM we are talking about, the 3 Pro, right? Earlier it was there. Gemini Pro or Gemini Flash. That LLM is doesn't have the capability of giving the this exact temperature, but it has an but it will take the query because it is an unstructured query, right? So I'm not, I will ask today like this. If I ask only weather in Paris today, or weather in Paris, or Paris weather, or Paris weather, or weather, comma Paris, if I tell anything, it will give you the correct answer. Why? Because your query has to be understood what is the intent, and then it has to be sent to a particular API and then get the result from there, and then it will maybe it pulled it from the Google weather. That is the API what Google is using. So this query is sent to the maybe sent to the LLM and then extracted the attributes from this. That's what we will see it in this example. Okay, so what is the weather in Paris today? So if you see, I have used Gemini, I think 2.5 Flash. Okay, so if you see the output, what is the output? Let me check the current weather for you in Paris. Okay. So it told like this. Okay. And it gave me an answer like current time is this one, current date is this one. Why this will all be wrong is because the LLM was never trained till today, right? How can it even give an correct answer? It cannot give. You agree with me? It can surely not give the correct answer. But the chatbot can give. The chatbot can give. How? Because that is what you wanted is, but this from this output, you think that this is the correct answer, right? But it is not, right? So what is to be done is you have to get the correct structured output from the model. Okay. So what is the correct structured output is, you see, this is what the LLM. Now I'm asking for a structured call. Okay, so this call is over. I'm not doing the unstructured call. So when I simply send that query to the LLM, it gives me this answer, which is not correct, right? So what I say to that is, I am trying to understand the intent. I am saying that these are all the tools I have. Okay, I'll show you the tools. These are all the tools I have, and this is how I initialize the model. Okay. And then now if I send this question to the model, what it does is it will tell call the tool this one, because that is where current temperature will be available. And it will give me a very good structured way, JSON format, a dictionary or JSON format, city name, or location, or whatever. Okay. So this is, you can use it in your code now to call your API along with this argument, which is the API. What is the tool? This is the tool. This is the argument. You will send it, and then you will get a. So you see. So based on that, you are now you. So you have a pydantic also. Pydantic is a way to validate it. Okay. So because LLM also will hallucinate while giving this. Okay. So you use a pydantic library to validate the data type. Okay, whether this is a JSON, whether this is a tool, okay, tool name, all those things you will validate. And then finally you will prepare the argument. Okay, so you have the argument and then you get the you use the unit and then the day and then you send it to that particular API and then you will get the answer. And that answer you can again send it to LLM, say that, okay, this is the correct answer based on the API call. Now you frame the answer for your original query which the user has sent. Okay. So this is the flow which happens at the backend. Okay. Understood this? We have to explain. So again, we'll see what I was talking about is what is the weather in
Parenting is
Paris.
guardrail. Can we say parenting is kind of a guardrail?
No, 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 no. It is a data validation library, not guardrail. I told you, no, it is going to validate whether it is a JSON format and it is a tool name string or not. Okay. It is not a guardrail. Guardrail is separate. That also will be there. That is the when you go to into the conversation system, we will discuss that in a different lecture. Okay. So so point is, what is the weather in Paris into language model? It will give you a text. Okay. So blah 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 blah. It will give you. Okay. But this is not correct answer. So the same prompt when you will now build a system. So instead of language in this language model is there. Okay. So now what happens? The same prompt you are sending. So this prompt you are sending it to, I will make a, okay, let me complete this diagram. So I have the tool. So just one tool I have just to explain this. So weather API, maybe to a Google weather. Okay. So what happens in the flow? Okay. So when the question comes, it goes to the language model and language model will tell, okay, now I have to use the tool. I cannot directly answer. Okay, I cannot directly answer because I do not have the data of today's temperature. So I have to call the tool. So what happens? Your code is here. You have a code here which has to take this input from here, prepare the code arguments, and then send it to the API, get the result, and then send it back to the LLM. And now the LLM has the context that it is 2 degrees Celsius, and then now it will be able to answer the query. Correct answer. Understood?
Yes, yes, sir. So I think, sir, you already explained, but how, how we will, how the LLM will or how our code will work if we have like multiple tools. I think you mentioned in previous sections, previous lectures
Mhm.
somewhere.
No, this is
Because
one tool
because
means you
tool
can put
also, like
100,
we need
10
to
tools
tell
also.
the LLM. Sorry.
Yeah, tell me.
So, sir, suppose we have like 10 tools or 12 tools or 100 tools, right? I mean, uh, that tools could also be dynamic.
You're
So
far
how?
ahead. Actually, that we will
Okay,
discuss after mid exam.
okay, okay, okay. ठीक
Okay.
है. Okay.
Okay. Now understand that this is uh, way to get a structured output so that you can use your code to call an API using a function. That's what. Now we'll go back to what I'm talking about. Will make a sense here. So now you see.
Can't we put that specifically in the prompt itself? Like I want a specific response in a specific format, or that will be different.
That is what I am explaining. This wait. So this is for the pydantic. Just leave it. We'll come back to this pydantic later. So this is the setup key generation, all these things. So now coming to the structured call. Okay. So what happens in the structured call is you are passing a tool. Okay. That is first thing. And second thing is you are giving the config. Now coming to the prompt. Okay, so now where is the user query? This is the user query. Okay, and here you have given a tool. Okay, so what is this tool does is actually here they have made it very more simpler. But what does this at the back end? What does it do is it will take this tools, whatever tools you have given. So here you have given tools, right? So this is the tool. It understands in a prompt way. Like, I guess in this the other one should be very more detail. Mm, hmm. Okay, here it is there. So you see in the structured call, what you say, like exactly what our friend was talking about. So it says you are a helpful function calling assistant. Okay. This is the first time when you call. So this is the between 1 and 2 I'm talking about. Okay. So there is a 2 calls. For correct answer, what you do, you are giving 2 calls to the LLM. First call is you are sending the raw query to the LLM and it produces the second step. And then your code is using that second step to send it to your weather API, whatever tool it is, and then get the response. The code gets the response as the fourth step. And now the fourth step, the response you got it in the code, you are to again call the LLM using the fifth line, and the LLM will produce the sixth step. Understand? So there are two LLM calls here. Okay, so
So we
understand
are,
that.
sir, so we are using LLM only to parse the natural query to a JSON format and then the result of the weather API to a natural language once again.
Exactly.
Is that correct?
Perfect.
Okay.
Yes, exactly. So here what we are doing, this prompt is for the first call. So you are a helpful function calling agent. Your task is to extract information from the user query to populate the arguments of a function. Okay. So you must respond only a valid JSON object matching this JSON format. Okay. So do not add any conversational text because I just wanted a perfect JSON format only. Okay. So in fact, this schema is also given. If you see the schema, where's the schema? Schema, schema, get instruction schema, and that is this one. So get instruction schema is whether params, this one, if you see here, this is the schema. So you are getting the schema from here, right? So LLM will give you the location, unit, and forecast days in that schema. So when you will write a class like this and get the model JSON schema like this from that function, you will get the schema in this correct format, what your LLM can understand. And when you pass that to your schema string, okay, as the input to your LLM, now your LLM will understand what exactly your output should be. Okay, and that is what you wanted also. And once you get that JSON, then you will use it to parse and then send it to a API, call the API, get the result. Okay, and then again you can send it back to LLM to generate an answer. That we have not done here, but you can do it. Okay, so currently we are talking about only the structured output, only the first to second wala concept. Okay, that is what we are concentrating in the code. Okay, but you have to, if you see here also, so this is unstructured call me. You have not specified a schema or specified it to produce only a JSON output, and you have not uh, told it to concentrate on the argument to give the arguments for a function. These three things you have specified in your prompt. So what happens is when you give this, it will give you exactly, it will not give you, in this case, it is structured, unstructured call. So it will give you, I am sorry, I'm an AI model. I don't have real-time access to current weather conditions around the world. However, you can easily check this in some website bolega. Okay. So that is the point in the unstructured case. But in the structured case, since I have asked it to produce, this is the model I have used here. So I have asked it to produce exactly that schema, right? You see the exact schema it came. This is the API response. The schema exactly came. Now location, unit, and forecast days. Exactly, this is the schema is required. That's what we asked for. So now you can easily extract the JSON, and then using pydantic, you will validate. So validate means you already have the function, you have defined the data types there. If you see here, we already defined the data. This is the call, and this is the data types: location, string. It should be string, and this is the schema. You don't need to worry about it. You have to give this, then only LLM will understand. Okay, so under how, just go through this. If you will understand how to prepare this schema for whatever input you wanted to give it to LLM. Okay, so this is the forecast, and it should be in int, and this should be unit, and it should be in temperature unit. Okay, so you can, so these are all available in your this one. What do you call? So temperature unit, you can define it. Celsius means Fahrenheit, Fahrenheit means Fahrenheit. Okay, so all these will be available in your pydantic. So this is the crux for keeping it, giving a correct schema to your LLM. So once you give the correct schema, it will also produce for whatever question you give, it will produce a perfect JSON structured output. Okay. So when it gives a structured output, this one, so now easily you can use your code to extract this JSON. And then you have the values like this, keys like this, and then values like this. Okay. So now you can call the API and then get the result. And now the result is exactly the latest result, right? The current result. So now if you give the same question and give the context as the correct answer, now the LLM will not say this. Okay, because it says what I don't have real-time access बोल रहा है ना. What you are doing is you are not telling it to give the answer. You are telling it to now give me a structured output of what is the query. Now your code will go and do an API call, get the answer, and then now you send this. Like we can now safely access the data using these three parameters to your API call, get the answer, and then pass it to the LLM, and then you will LLM will be now able to answer the question. Okay. So same way another question also we are sending. Same way, if you see, it will say that it doesn't have access, and same way it will give you a very correct answer format, JSON format. And once you get the JSON format, it is simple, right? So that's what you have to do. So once, if you see here, so between 1 and 2, you have one call. And once you get the call, this is the code you have, right? This is the code which will process your structured output, take the JSON, send it to your APIs, and then you get the output in your code, and then you send this current data along with your original query. This is your query, right? So this is your original query coming from your this one. So while sending this data, you will send query plus this API result. Okay, API result. So query plus API result. So now the LLM has the question as well as the answer. It has to just prepare a professional and humble, whatever the way you want. You can write this prompt here. So we saw the prompt between one and this first call. Second prompt, second prompt you have to write. You have to write. Now I have given you the API call results for the query. This is the query also. So this is the query. This is the API call result. Now prepare a user-friendly answer to be displayed to the user. Okay. So now it will prepare a very good answer, and that you can send it to your user. Okay. Simple. And now the question comes in. This is just one tool what we saw. There can be like 20 tools. There can be 100 tools also. That becomes more complex because LLMs, that schema what you give for every tool counts as tokens, right? So you cannot give 100 tools ka schema. So that becomes complex, that we will see in further class. Okay. So when we go for MCPs. Okay. So till then, this is sufficient. Okay. Understood this concept you understood?
Yes, sir. So here, this
Hmm.
base class. Uh,
Mm-hmm.
so can we scroll
Mm-hmm.
up in the code? this
Mm-hmm.
weather tool we have implemented this base model, right?
Mm-hmm. This one.
Yes, sir. So
Mm-hmm.
this class is understood by the Gemini tool thing, right? Uh,
Anybody will understand. Any LLM will understand. You don't need to write this much professional. In fact, before 1 year, we didn't even use Pydantic in our models. We directly mentioned it here. Like instead of this schema string, what we are giving nowadays, you just remove this and tell that you must respond with only a JSON object. With this karke, you can give the object here itself. That
okay.
whatever is the
Yes, yes.
format you wanted to, you can take it. Whatever format you wanted it to give, that you just
Mm.
put it there. So it will understand. That is, this is the old style, but nowadays that Pydantic has come, it will give more description. So what happens is many times LLM will not give correctly. So what we used to do is we add a description here. This is all old style, but nowadays you have all these things in this. If you see, so you see the description. What does this location mean? It is a city or a state. What does this unit mean? This is the temperature unit to use. What does this forecast days mean? Number of days to forecast. So default is one. If day number of days are not given by the user, just use default as one. So all these options are given nowadays. Okay. Earlier we used to write a prompt for this. Like we will write like this, tell that and then give like this and then default is one, something like that. You understood, right? So
Right.
instead, nowadays we have such kind of easy way to give like this, so that you write a function and then you like just get the JSON of that class. You write a class, not function. Sorry, this is the class. You just
Right.
take that and then model JSON, and then this schema you pass it to your LLM.
So okay, this
Mm.
custom prompt which we wrote, right? Like,
Mm-hmm.
I mean, we can wrote it many ways, the similar thing, right? And we can
Mm-hmm.
hope that LLM will give us the answer in that format. I mean, is there a
This
recommended
is the
way or
best format as on date. So
okay,
as I told you, before 1 year, we didn't use this. Before 1 year, we used to do this manually here for every tool. So, and
okay,
another thing is this is for one tool, right? So if we have to write here, so this was the format earlier we gave. Okay. So it is like tool one, yeah, we'll write now weather tool format. Okay. So, and then suppose I have another tool in this same LLM. I'm giving two tools here. So I will just give, maybe it is a Wikipedia tool. Okay. So uska format and this is
yes,
the
yes.
topic I
Sir, this
need,
part I
something like
understood.
that.
My
Okay.
question was something like we wrote this
Hmm.
thing like this is hard coded, right? Once we
Hmm.
we
So this was
like
old style. Nowadays we
uh,
have different style. Yeah.
no, no, sir.
Yeah.
This schema also this I mean, apart from this parameter schema which is present, there
Hmm.
is another set of description, right? That you are helpful function calling assistant. This is
Hmm.
hard
Hmm.
coded
Hmm.
everything. So
Yeah. This is the static content, what we were discussing earlier. Yeah.
okay. I mean, this is, I mean, this is there a how do we know that this is the format it should sub
Can
understood?
write
I mean,
anything.
right?
It is by you. This is like speaking to a person, right?
Okay.
So it's
I
like
mean,
you
sir,
you
this thing
you
which
can
you wrote,
write.
right?
If you
I
change a
can write
little
it
bit
many
grammar here
ways.
also, it will understand. Yeah, yeah, yeah. Tell me.
Yeah. So my question was like this part which is static here, right? We can
Hmm.
write it many ways. I mean,
Yeah, you can write any way you want. You don't need to even mention. You just simply write this. It is sufficient for it. It will understand. Nowadays, LLM, big LLMs will understand. Just that you have to write in English format. If you know to speak, right? Same thing you are trying. You don't even mention this. This is always an extra stuff. Reduce that. Just write this. Your task is also not written. Extract
mhm,
information. No. Just write. Mm,
mhm.
extract the arguments.
Okay, so
Just
only the
let me
yeah
write.
that
Um,
will also work. I understood your point.
mm, mm,
You
mm,
don't need to add
pro,
multiple things
mm,
there.
arguments for the tool tools right below. Suppose I have two tools. Okay, tools
Mhm.
arguments you write arguments for the tools from the given query. Yes, this is sufficient. This is sufficient. Nothing is what to give. Ideally,
Okay.
this is more good than that the other one because this is less number of words.
Tokens.
Because tokens, you
Yeah.
are not wasting money because when you're calling any API, cost is there. And this do not add conversation access. It is required most of the cases older logic, but nowadays if you don't give also chalega because this itself is very robust. The only thing is you have to write this if you are giving more this one this is like more tools. You can write like tool one. This is like this. Name is this one. Whether uh, and this the arguments like this. This is more important. Okay. So next one, tool two, you have to write. Nothing
So
is
this is
correct.
more
Maybe
of
some
prompt
LLMs are very
engineering, right?
intelligent
Sorry.
without even you write. Huh?
So this is more of a prompt engineering, like how you write a good prompt so that
Not
it is
big engineering.
understood
Yeah. You
well.
can write easily. This is
Achha.
just that you are talking to your friend. It's
Okay.
just that, see, again, it is, there is no, nothing called as this is the correct way.
Okay.
Again, it depends on two things. One is how, what you wanted. Second thing is how well your LLM understands. So since we are using, which is the model here, we are using this
2.5 Gemini.
Queen.
Okay.
So
Okay.
Queen
Okay.
model will be small, right? This may not understand. But if you go to Gemini, which is 2.5 Flash, is a like very big model. इधर तो
Okay.
आप सिर्फ स्कीमा भी देगा तो it will be able to understand. Just that give only this part what we are talking about. So for Gemini,
Mm.
it will be very intelligent to understand only this one. You don't need to even write all this crap because bigger the model, it will self under. Oh, at least this much you should write. Given query
Mm.
करके you have to give the query, and this is the query we are already passing. This system prompt में you don't need to mention much. Okay. So this is actually system prompt. We normally write everything in this here itself, olden days. Okay. So it depends on what you wanted. So bigger model is more intelligent to understand all the things. Okay.
Got it.
So,
Thank
but
you, sir.
you
Thanks a
can,
lot.
that is why you have to do some like trial and error. Okay, so you
Mm.
can remove this and see still it is able to give in this format or not. Understood. Like here
Understood,
also,
sir.
I think we can remove it and then see. Let's remove this also. At least this one respond with only this one. Okay, but it will take a lot of time. Actually, this model is very slow. So if it is switching on now, it will not even answer. Okay, everything gone. Actually, I have to run it from top. So it will take more time. We can do it in next class if you want. Okay.
Okay.
So this is the point. I hope you understood, right? So this is the simple thing. The same thing, everything is in the slide is same. If you understood this, the slide is fine. You can go through and understand whatever is there in the slide. So how we get the JSON schema. Okay, so we'll see this next class, no problem. We are fast already. Any other question? Oh, 6-5. Okay. Oops, I have a Viva, I guess.
So today,
Okay.
quiz is also planned. May I know whether it is there?
Pizza. Yes, yes. 7 o'clock. Say 7 or maybe 9 o'clock. Say it will be there.
Okay. Okay, sir.
If no, so just keep checking after 9. It will be surely there. Okay.
Okay, sir.
Hmm.
Yeah. Thank you.
Okay. Yeah. Thanks. Okay. Anything else? Any questions?